Now we are seeing about subsetting nested elements of a list. Let's say there is a list within a list 1, 2, 3, and then there is a vector which contains values 1.5, 1.6. Now this is the list created. Now if I want to extract only this value 3, how can I extract it? Is if I use x of double square brackets, and if I use 1, 3 without the quotes, and if I use this, I'll be directly pinpointing to this 3. Now I should be declaring the C of 1, 3 as it is a vector. Yeah, now it is pointing to 3. Now we are able to extract this. Now let's move on to partial matching. Let's say we have a list which corresponds to ABC AARD something equal to 1 to 5. Now if you display this x $A, you'll find 1, 2, 3, 4, 5. Now let's say the dollar symbol is actually retrieving 1, 2, 3, 4, 5 because there's a partial match with the element AAARD. That's why you are able to extract 1, 2, 3, 4, 5. The partial matching is allowed in dollar, whereas in this case x double bracket quotes A, if I use this, it will return null. This A is not matching with this. Now if I use the exact parameter as false, I'll get 1, 2, 3, 4, 5. Partial matching works in case if you are using exact. Now removing NA values. Last time we saw about identifying NA values using s.na function. Now to remove NA values, how can I do that? Let's say there is a vector which contains values C of 1, 2, 3, NA, 4. Now I want to, when you display X, you will find that there is an NA value inside this. So how can I remove this NA value from the list, from the vector? Let's say I define a value bad which will have, now I'm using this is.na function to identify the NA values in X and assign it to bad. Now if you see what the values in bad, it will be a boolean thing containing false, 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 true and false. The true indicates there is a NA value within X. Now how can I remove it? If I use X of not symbol, which is an exclamatory mark, and use bad, it will remove NA value and it will give me 1, 2, 3, 4. This is normally used in data cleaning purposes, where you want to remove NA values from your data and the data will be more cleaner than before. Now moving on, removing NA values. So let's say you want to take the subset without the missing values. How can we do that? Let's say there is a vector X which contains 2, 3, NA, 5 and this. And there is a vector Y which contains B, NA, C. It's a character vector which has an NA value. Now you can see this. Now if you want to have only the good values, which I'm indicating here, which are not NA, so using complete dot cases of X, Y, which will give me, okay, as the argument lengths are not same, now I have to change the argument length of Y to contain one more, as it was earlier having 4, now I'm having 5. Now if I use good of complete case again, it will work because the argument length for Y and X are now same. So if I use good, now you get true, true, false, false, true. Now if I use X of good, I'll get only 1 to 5, which means in 1, 2, 3, NA5 corresponding to 3 there was an NA in Y. That's why I was not able to get. It combines both X and Y in a columnar fashion and finds only the good values of X and now the good values of Y, A, B and D. So now we have removed all NA values corresponding to each and everything. Now moving to vectorized operations. So like many operations in R are vectorized, making code more efficient, concise and easier to read. Let's say you have X to be a integer sequence 1 to 4 and have Y to be a sequence 6 to 9. Let's say you want to add both. It adds 1 plus 6, 2 plus 7, 3 plus 8 and 4 plus 9. So these kind of operations will make it even more simpler. As you can see in these examples, if you use x greater than true, it will give you a boolean a value false, false, true, true. For whatever values which are greater than 2, you will get true, and which are less than 2, less than or equal to 2, you will get false. Same way for greater than 2 and double equal to 8, which means the value equal to 8, which is true for only 8, and others it will be false. Now you can do x into y also, which will give you 6, 14, 24 and 36. It will come from x of 1 to y of 1, it will multiply the same way for x divided by y. Now moving on to vectorized matrix operations. The same way we did for vector operations, same way it corresponds to matrix as well. We have a matrix 1 to 4 matrix, and we have a same level of matrix here also. And when you multiply that, it should have the same number of elements to perform element wise multiplication. So to perform true matrix multiplication, you can find this is element wise. So 1 to 4 and 10 comma 4, it's get repeated, which means 10 4 10 4. So it will be 1 into 10, 3 into 10, again like 2 into 10, this is 4 into 10, which here this 10 is repeated 4 times. The matrix contains value 10 4 times. So same way for x divided by y, and to perform true matrix multiplication, you have to perform it with x percentage star percentage y. This I will not do in the console, as you should try this at home and you can learn better from it. Now we conclude with this session. We will see in the next session.